Okay, so here is our lecture video for section 10.7, write and graph equations of circles. This is our last section of chapter 10. So we made it all the way through chapter 10. This is our last thing with circles. And we're just going to learn what the equation of a circle is and how to graph it. So to start, what is the equation of a circle? So let x, y represent any point on the circle. So x comma y, just any point on the circle with the center at the origin. So just remember origins at 0, 0 when we think of like a coordinate grid, and the radius is r, so any number r. If we were to use the Pythagorean theorem, so remember Pythagorean theorem, a squared plus b squared equals c squared. Looking at our triangle over here, xy is this point right here on our circle. Our radius is the segment connecting the center to that point, so that's r. The height of this triangle they drew is the y because it's our vertical distance, and the length or the base here is going to be x, horizontal distance. So basically looking at this, the r becomes our c, and then the x and the y become our a and our b in Pythagorean theorem. And we get this equation right here, x squared plus y squared equals r squared. And this is the most basic circle equation that we can have. Center at the origin, it's just x squared plus y squared equals r squared. And that's our equation. But this is only for when it's centered exactly at the origin of our coordinate plane. X squared plus y squared equals r squared. So let's take a look at an example where that's the case. They give us a circle and they want us to write the equation of said circle. Well, first off, we have the center. So what's our center of the circle? Well, it's the origin. It's 0, 0. And then we have to figure out what our radius is. Well, we can do that just by counting 1, 2, 3. It should go out 3 in all directions, so we're good to go. So our radius is 3. So then we have this equation here, x squared plus y squared equals r squared. Well, the x squared and the y squared aren't going to change because it's centered at the origin. So x squared plus y squared doesn't change. Our radius is 3, so this becomes 3 squared, which means our final equation is x squared plus y squared equals 9. And there's your equation of this circle right here. So some calculators, you can plug this in. Later on, you go more in depth with circles and do a little bit more with this. But there's our equation of a circle with the center at the origin. Easiest case, basically x squared plus y squared equals radius squared. You just have to figure out what the radius is, which is really easy to find just by counting. Where it gets a little bit more difficult is when it's not centered at the origin. It's not right smack dab in the middle of our coordinate grid. And we say these circles are centered at h comma k, and we just use this to show our center. I'm just kind of reading along with me here. You can write the equation of any circle if you know its radius and the coordinates of the center. So you need two things to write the equation of the circle, the center and the radius. So suppose the circle has radius r and center h comma k, and there's a point x, y on a circle. So they just, by that sentence, they just created this circle right here they gave us. The distance between x, y, and hk is the radius, just like we said before. The distance between the center and that point on the circle is just the radius. And to find that, we can use our old friend, the distance formula, our x2 minus x1 squared plus y2 minus y1 squared, all underneath the big square root, to figure out what that r would be. So distance formula is coming back into play here, and from that we derive the standard equation of a circle. So of all this stuff to write down, you need to write this equation down. You want this memorized, you need to have it written down. This is what we're going to be using moving forward through the rest of this section. X minus h squared plus y minus k squared equals r squared. So it's still x plus y squared. Now we just have this minus h minus k because we're not centered at the origin. Something I want to point out here is it's directly derived from the distance formula, which means it's minuses inside the parentheses, addition outside. So basically, always opposite inside the parentheses, and then you're adding in between, and then r squared. Don't forget to square your r. So let's see an example using this formula, this standard form of the equation. Okay, write the standard equation of a circle with the center 0, -9, and a radius of 4.2. So we said we needed two things to write our equation. We needed a center and we needed a radius. And we have our equation that's going to be x minus h squared plus y minus k squared equals r squared. I just rewrote that standard form in case we needed it. Well, our center is h comma k. Learned that from the last slide. Our radius is 4.2. So we just need to plug those numbers in. The x and the y stay the same. Don't mess with the x and the y. We have x minus 0 squared plus y minus -9 squared equals 4.2 squared. So all we have left to do is to clean it up a little bit, and it's not even going to be as bad as you think. X minus 0 is just x. So we're left with x squared plus y minus -9 is just y plus 9 squared equals 4.2 squared. You could do it in your head, do it in your calculator. It's going to give us 17.64. And there's our equation of the circle. Not too bad. The thing you have to be careful with is the negatives here. That's going to change it from a minus to a plus. Remember, it's always opposite inside the parentheses. Whenever you have a 0, you can just leave it as x or y, depending on where the 0 is at. So why don't you guys go ahead and try these two on your own and come back when you're ready to check your answers. All right, so we have a center at 0, 0, radius at 2.5. Well, since the center is 0, 0, I know I'm just going to have x squared plus y squared, because the zeros aren't going to change anything, equals my radius squared, so 2.5 squared, which leaves me a simplified equation of x squared plus y squared equals 6.25. Number 2 is a little bit more difficult, but not really. We're going to go back to that standard form of equation that I told you guys to make sure you knew, have it written down. X minus h squared plus y minus k squared. We're going to have x minus -2 is going to change this to x plus 2 squared. And then y minus 5 squared equals radius squared. 7 squared is 49. And that should be your answer for number 2. Again, the reason I changed this to a plus 2 is because this was negative and we go opposite inside parentheses. Since it's positive here, we go negative there. The square and the addition are just staples. It's part of the equation. Square your radius. All right, so that's kind of just the basics. When they give you the information, tell you to write the equation. Another type of problem you might see with this, it's a little bit more work, but still not that hard. So say we have the point -5, 6 is on the circle with the center at -1, 3. Write the standard equation of the circle. Well, before I said there's two things we need to know before we can write the equation of the circle. That's the center and the radius. The center is right here. We have our center. We have our h comma k. What we don't have is the length of this radius right here. We don't know what this is. So we're going to have to find it. And since it's a slanted line, it's not a vertical line, it's a slanted line, we are going to use the distance formula. Are there ways around this? Yeah, there are. But I want you guys to get used to using the distance formula and be comfortable with the distance formula, so we're going to do that way instead. We're going to find the radius. And remember, our distance formula is d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we're finding the radius here, we know r is going to equal the square root of x2 minus x1. So we could do -1 minus -5 squared plus y2 minus y1, 3 minus 6 squared, and we can clean this up. -1 minus -5 is -1 plus 5. 4 squared plus -3 squared, which gives us 16 plus 9, which gives us square root 25, which is 5. So r equals 5. So now we can just plug that into our formula and get that x minus h, so then x minus -1 is going to be x plus 1 squared plus y minus k, y minus 3 squared equals r squared, 25. And that would be our equation of that circle. Were there ways around this? Yes. This piece right here is also a radius. 1, 2, 3, 4, 5. Could have found the radius that way, but it's always good to remember that distance formula. It's good practice to try that on your own. Because what if they didn't give you the graph? Are you going to take the time to do the graph on your own, or are you going to use the distance formula? And that's exactly what I want you guys to try to do on these examples right here. Come back when you're ready to check your answers. Okay, number 3, the point is 3, 4, and the center is 1/4. Again, we need to find the radius, so we're going to use distance formula. So r equals, I'm going to do 3 minus 1 squared, 4 minus 4 squared. To get that, we have 2 squared plus 0 squared. Well, 2 squared is 4, which means our radius is 2. So then if I plug all of this information into my equation, I will have x minus 1 squared plus y minus 4 squared equals 2 squared, 4. So there's that equation for number 3. And then for number 4 here, again, they give us the center but not the radius, so we're going to solve for it. I'm going to go this way to try to avoid some negatives here. 2 minus -1 is going to be 2 plus 1 squared plus 6 minus 2 squared equals 3 squared plus 4 squared, which equals 9 plus 16, which is 25. Square root of 25 is 5, which means 5 is our radius. So if I plug this into my equation, I get x minus 2 squared plus y minus 6 squared equals 5 squared, 25. And there's our equation. And that's why I told you guys to use the distance formula in the last example, so that you can do these types of problems when you're not given the actual graph. So keep moving forward. We've had a lot of practice of writing the equations, so then now let's practice when we're given the equation and we want to graph it. Let's see how our graphing skills are. Looking at this equation right here, I have all the information I need to graph this. I have my center and I have my radius. So remember, we have our h, our k, and our r. So first thing I want to figure out is what exactly is the point, the coordinate of my center. Well, it's opposite, so since this is -4, it's going to be 4. And since this is +2, it's going to be -2. So 4, -2 is my center. And my radius is the square root of that, right? This is r squared. So the square root of that radius is going to be 6. So now we're just going to start graphing it. So the first thing I want to do is graph my center. 4, -2. 4, -2. There's my center of my circle. And my radius is 6, so I know I'm going to go off 6 in each direction. The easiest thing to do is to go up, down, right, left, to do the 4 that are easiest to count. So I'm going to go up 6, 1, 2, 3, 4, 5, 6, right 6, 1, 2, 3, 4, 5, 6, down 6, 1, 2, 3, 4, 5, 6, and left 6, 1, 2, 3, 4, 5, 6. From here, I'm just going to do my best and, make a circle. It's not going to be perfect. If you are a perfectionist, you could break out your compass. I left mine at school, so that's as good as it's going to get. And that's how you graph it. All right, so you just take what they're giving you, point the center, do your radius, draw the best circle you can. This is actually a pretty good circle for me. So yeah, that's a win in my book. So let's try a word problem that likes to come up with circles with graphing them. So we have the epicenter of an earthquake is the point on Earth's surface directly above the earthquake's origin. A seismograph can be used to determine the distance to the epicenter of the earthquake. Seismographs are needed in 3 different places to locate an earthquake's epicenter. If you guys didn't already know this, you need 3 of them to pinpoint the location. And they gave us the seismograph readings for 3 locations to figure out where exactly this earthquake is happening. So, before we even get into graphing these, we're going to see how these work out by graphing them. These are our centers. A, B, and C is the center. Miles away is the radius. So we have everything we need to graph it. We don't need to solve for anything or anything like that. So we just need to practice graphing. So I'm going to bust out my graph here. You guys could do your best to sketch it. You could even pull up something online to help do it so you can pinpoint it as well, like a Desmos or a GeoGebra, some different things on your iPads or your Chromebooks. So the first thing I want to do is just I'm just going to draw all 3 circles. So circle A, the center is at -2, 2.5. So it's up here. Again, we're just going to sketch it. It's going to be estimating. We're just going to sketch it here, and the radius is 7. So I'm going to count 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right. Again, I could break out my compass here, but I'm just going to do my best to draw my circle in, because again, we're just sketching it. It never has to be perfect. There's circle A. Same thing for circle B. So our center is at 4, 6. So that's going to be up here. Our epicenter is 4 miles away, so that means our radius is 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. All right, there's circle B. So we're gonna do our best to draw this guy in. Okay, last but not least, circle C. Center is at 3, -2.5, so 3, -2.5 with a radius of 5, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4. One more. Can't count. Okay. So ignore that dot right there. Just ignore that. This is circle C. Do my best to kind of create this circle here. Okay. So the answer to this, where is the earthquake's location, is where all 3 circles intersect, which from the looks of it looks to be somewhere around here, right? Because our circles are a sketch, so it's kind of an estimate, so that's okay. Yours would have been more exact if you would have done it on, say, Desmos or GeoGebra. But where they all 3 intersects our answer, it looks to be about 5, 2 would be the center. And that would be our answer for this question. These pop up a lot with circles because they're kind of fun and cross-curricular with science and whatnot. Kind of a lot of work, but again, they took away a lot of work by giving us the center and the radius, and it's where the 3 centers intersect is where the epicenter of the earthquake would be. So I want you guys to go ahead and try these last few guided practice problems on your own and do your best to sketch the graphs of those circles. Come back when you're ready to check your answers. Okay, so for number 5, I'm not actually going to graph it, but the center of your graph, the center of your circle, should be at 4, -3, and it should have a radius of 4. So if you have a graph, a sketched graph with the center at 4, -3, radius of 4, you'll be good to go. Number 6, your center should have been at -8, -5, and your radius should be 11. Again, sketch your graph And then for number 7, why are 3 seismographs needed to locate the earthquake's epicenter? Well, if you think about it, when we just had A and B, circle A and B up here, they intersect at 2 points, which means there's 2 possible locations. By adding that 3rd circle in, it pinpoints which one of those locations it is, and that's why you need 3. All right, because when they intersect, there's 2 points when circles intersect. And that wraps up Chapter 10 and Section 10.7, writing and graphing equations of circles. So here's your homework, 4 through 24, evens. And email me if you have any questions.